All right, welcome back to the night class. We are speeding our way through chapter 8. All right, 8.4. Perpendicular vectors. First off, perpendicular means what? 90-degree angle, okay? So I have written here two vectors, and they are perpendicular. And what I'm about to show you, you don't have to write down. What I'm about to explain is why this inner product thing works. Okay, and you'll see what I'm doing here in a second. If I were going to solve this, we talked about this yesterday. I could make another vector right here, vector BA, okay? And what did I just make? What kind of triangle?
90, 30, 60.
A right triangle, okay? Not necessarily a 30, 60, 90, but just a right triangle. So if I were to solve this, okay, and I would square both sides, right? What happens to the square root on that side?
Cancel.
It cancels. So I'm left with this vector BA squared equals A1 minus B1 squared plus A2 minus B2 squared. And understand, where am I getting those? Well, I'm getting this vector A from A1 minus B1, okay, just like we did yesterday, and vector B, A2 minus B2, same way, okay? This is how we got the vectors yesterday. That's what I'm doing, same thing today for this final one, okay? If you multiplied that all out, you would get A1 squared minus 2A1 B1 plus B1 squared. That's for that one, okay? Plus, if I did this one, it would be A2 squared minus 2A2 B2 plus B2 squared. And that would be for that one, multiplied out, okay? Then if I rearrange, okay, all I did there was FOIL, okay? I just multiplied it out. So if I rearranged and I put A1 squared plus A2 squared together, these two, okay? And then I put plus B1 squared plus B2 squared together, all right? And then that would leave me with minus 2 A1 B1 minus 2 A2 B2, okay? Again, all I did was rearrange it, and everything I'm writing on here is on page 505, okay? What can I take out of this? What do they both have? The minus 2, okay? So let me scroll down a little bit. This part right here, okay, I think I'm highlighting it. That is actually the same as vector A squared, okay? This part right here, that is actually vector B squared. That's what that would equal. And if I take out that negative 2, if I factor it out, I would have A1 B1 plus A2 B2. That part right there in green, that is known as your inner product. And we're going to talk about the inner product. Because for these two vectors to be, let me write down, this was vector BA squared. This is vector BA squared, that's that one, okay? A squared would be this one, B squared is this one. What is that part? Y'all see it? Pythagorean theorem. Thank you. It's the Pythagorean theorem. So for this to be a right angle, the Pythagorean theorem has to work, right? Back in Coach Glover's class in geometry, if the Pythagorean theorem works, or if it's a right triangle, the Pythagorean theorem works. And if the Pythagorean theorem works, then it has to be a what? A right triangle. It's converses of each other, okay? So if this has to be true, what does this have to be?
True.
What's in the highlighted green portion? What would that have to be? what number?
0.
0. Why does it have to be 0? Because does the Pythagorean theorem have -2 times some number on it, on the end of it? No, it just has a squared plus b squared equals c squared. So this part right here, that's the Pythagorean theorem part. So for this to be true, this part has to be 0. Okay? This part that I have highlighted is the inner product. Okay? You're multiplying, but not like you usually multiply. Okay? That gets us to right here. The inner product, it's also sometimes called the dot product because they always use a dot when they're multiplying right there. Okay? But the way you do the dot product is you say A1 times B1, okay, plus A2 times B2. Finding the inner product is not hard at all. Okay? That's all you have to do. A1 times B1 plus A2 times B2 equals whatever number you get. The inner product is a single number. You'll get like 54, or you'll get 2, or you'll get 0. And if you get 0, you know that these two vectors are what to each other? Perpendicular. Because they have to be if it's 0, because then the Pythagorean theorem works. Okay? If the Pythagorean theorem doesn't work, if you have something besides 0 here, you know that these vectors are not what? Perpendicular. So if the inner product equals 0, they are perpendicular. Okay? Everybody is just ecstatic. I can't. This is wonderful. All right, so example 1. Find the inner product if vector P is 7, 14, vector Q is 2, -1, and vector M is 3, 5. Are any pair of vectors perpendicular? Okay? So all we're going to do, we're going to plug in our vectors. What's vector P? 7, 14 times the dot product with Q, which is 2, -1. Okay? So, again, real easy math here. What do we do with the first two numbers? Multiply them. 7 times 2 plus, what do we do to the second two numbers? Multiply them. 14 times -1. What will that equal? 0. So, the inner product is 0. Are those vectors perpendicular? Yes. Why are they perpendicular? Because the inner product is 0. If it's not 0, it's not perpendicular. Okay? 14 minus 14 would be 0. Everybody with me? Easy peasy. All right? P. 7, 14. Got my 1. Inner product with Q, which was, no, M. What was M? M was 3, 5. Okay, same process. 7 times 3 plus 14 times 5. I don't know why I put 15. What is 7 times 3 plus 14 times 5? Not everybody scream it out at once you have. That's a joke. Please scream it out whenever you get it.
125.
Not yet. 91.
That was a good guess.
Are those perpendicular? No. It is not perpendicular. Okay? This one was, because again, what was my inner product? 0. All right? Last one. Q, 2, -1. Dot product with M, which was 3, 5. 2 times 3 plus -1 times 5. What would that equal? 1. Perpendicular or no? No. Not perpendicular. Okay? Pretty simple on the inner product. Okay, example 2. We're doing the same thing, How many dimensions did we have in example 1? 2. Example 2, we have 3. You think you do anything different? No, you just add one more number to it, okay? Same process, exact same process. So we're finding the inner product. That's going to be -3, 1, 1. Inner product with 2, 8, -2. So we have -3 times 2 plus 1 times 8 plus 1 times -2.
Still going wrong.
-3 times 2 is -6. Plus 1 times 8 is 8. So -6 plus 8 is 2. 1 times -2 is -2. What's 2 minus 2? 0. Is that perpendicular? Yes. They are perpendicular. Everybody good on inner product? Okay, no problem. So, that was the inner product. It's the easier of the two products. We're going to find another product called the cross product. And y'all remember that day when we were doing matrices and we were finding the determinant of a 3x3? And I told you, I was like, hey, there was 2 ways to do it. And I was like, hey, you can do it this way or you can do it this way. But this way, you're going to use later on. We're to that day. Okay, we're using what we've learned before, okay? To do the cross product of 2 matrices. First off, the matrices, 2 vectors. I want you to understand the answer to an inner product question is a number, one single number, okay? The answer to a cross product question is another vector. So, I got 3 meter sticks here, okay? These 2, are they perpendicular? No, they're not, okay? They're just intersecting. But what the cross product does is it takes 2 vectors that you may have and it finds a third vector that is perpendicular to both of those vectors.
Is this kind of like the same thing we did?
Yes. What, I don't know what you're talking about. It's the same thing we did when?
Like a few weeks ago. Like where you had to do the...
The cross product is, yes, Yes, we did the cross product a few weeks ago. You didn't know it was the cross product there. Okay? So, you get to try again. Okay? So, again, so your answer to an inner product will just be a number. Your answer to a cross product question will be another vector. Okay? So, here is the definition of it. As you can see, we're cross product. They use a what? For the symbol, an X. Okay? Dot product, they use a dot. All right? Or inner product. So, all this is...
And our vectors are only 3 dimensions.
Yes. Shh.
We won't have to draw all these, right?
Depends on the load.
There's your matrices. Okay? You're going to know these 2 rows. The top row are your unit vectors. Okay? If you remember, when we did these, the middle one, we always did what? Opposite. We changed the sign. That's why down here, it's minus on the second one. Okay? And all you're doing is you're taking that top row, if you don't remember, okay? You say I times that little matrix, and that's what's here. Okay? Remember, you cross out the row and the column that one's in, and what's left is what you write down. Okay? And then you do the same thing for the J and the same thing for the K, except for J, it's what? Minus. Okay? So you have done this before. It's just been a minute. Okay? It was like back in whatever the Matrix chapter was. You said a couple weeks. It's probably been a couple months, to be honest. Okay? So, example 3, let's just do one real quick. Where's I don't want to do all that. I just want to go down. Whoa. 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 Okay. I'm okay. Okay. No, I'm not okay. I just want to go down. Hey. Keep going. There it is. Okay. So, cross product with vector V and vector W. All right. Here's vector V. So I'm going to make my matrix I, J, K. Those are my unit vectors.
So they stay IJK.
They stay I, J, K. Okay. Those are my unit vectors.
Say that 3 times fast.
I, J, K, I, J, K, I, J, K.
Oh,
0, 3, 1. And then 0, 1, 2. Okay? And I work that out. So I write I. And what would go with vector I? 3, 1, 1, 2.
Why?
Because I take out the column that I is in and the row that I is in, and I put those 4 numbers. Okay? Minus J.
It's
Again.
always going to be minus J.
Yes. It will always be minus the middle. Okay? I take out the column it's in and the row it's in, and I'm left with 0, 1
0, 2.
and 0, 2 plus K. Take out the last column in the top row. I have 0, 3 and 0, 1. Okay? Do y'all remember how to find the determinant in there? Let me remind you. So we're going to have I cross multiplying. 3 times 2 is what? 6 minus 1 times 1 is 1. The thing you got to remember is you're cross multiplying and subtracting.
Can
Okay?
you repeat that?
3 times 2 minus 1 times 1. Every time. Okay? Minus J. 0 times 2 is 0. Minus 1 times 0 is 0. Okay? Plus K. 0 times 1 is 0. Minus 3 times 0 is 0. So, I end up with 5 times vector I minus 0 vector J plus 0 vector K. Okay?
Okay.
Does it matter how you write those? Like the 0 and the J?
No, not really. You could you're writing it as a sum of unit vectors. So technically you didn't really need these because 0 times those, it goes away. But I'm writing them, I don't know where that came from. I'm writing them just so you see that it does go with those letters. Okay? So this is, remember yesterday you had some vectors that you wrote as ordered triples and some as the sum of unit vectors. Okay? So this is the sum of unit vectors. If I wanted to write it as a triple, I would just put 5, 0, and 0. Okay? So that's my cross product. Again, the answer to a cross product question is another vector. The answer to an inner product question is just a number. 6, 10, 15, 20, whatever. Okay? Yes.
Can you pause that? Let me write that down.
So, now that we have our answer, the second part of the question says to verify that the resulting vector is perpendicular to vector V and vector W. So we're going to take our answer and verify that it is perpendicular to our other 2 vectors. And how do you verify if something's perpendicular or not?
The inner product.
You do the inner product with them. So we're going to take our answer, 5, 0, 0, and do the inner product with the 2 vectors that were in the question. So the one vector was 0, 3, 1. And then we had the other vector was 0, 1, 2. And we need both of these inner products to equal what? 0. If it doesn't equal 0, something is wrong. So 5 times 0 plus 0 times 3 plus 0 times 1. Well, that's an easy one. What's that all going to equal? 0. Everything's being multiplied by 0, so it's 0. So that one checks. Boom. That one is perpendicular. Okay? Same thing for the second one. 5 times 0 plus 0 times 1 plus 0 times 2. They both check. We verified that is perpendicular to both of those, so we probably got it right.
Will one check and the other one won't?
I haven't had that happen, but I assume it's possible because it could be perpendicular to one vector and not to the other. But that's only if you did something wrong. Okay? If you do it correctly, they should both check. Okay? So
is that part of the problem?
that was part of the problem, yes. All right? And that's our last problem of the day. So I hope this helps. See you next time, and as always, stay above the line.